Hello, my name is Jadu Das. I'm a professor in remote sensing at the University of Southampton. I'm going to cover a little section where I'll talk about role of remote sensing in characterizing sargassum. So particularly how we look from individual points to a satellite level. So this is a work that is done by many colleagues across the team. So when it comes about remote sensing, so in particularly monitoring sargassum, we can ask three questions. The first, we want to know where sargassum is, and this is where we can utilize the satellite data set to give us a regional and global perspective. But then once the sargassum started to beach on a specific coastal areas, then we want to ask question how much of that being beached. And this is where we can utilize some high-resolution data sets such as unmanned aerial vehicles or drones. And then once that is there, and then we may need to identify what are the different types of sargassum, what are the different species of them, because they might have different value in terms of their usage. So this is where we can utilize some close-range field spectrometric data set to understand different signature from different species. So putting all this together can help us to develop an early advisory system because of those understanding of those areas. So why satellite remote sensing? Because we are in an era of what we call big Earth observation data. So this is an example from European Space Agency, different type of satellite missions. So if you see from 2000 onwards, so there is a increasing number of satellites are available, which provides data on different aspects of our environment. And this is so up to now, we got around 20 plus satellite data which we can collect and utilize in different environmental monitoring. And this is just European Space Agency. If you think about other the NASA, the JAXA, and the other areas, so they also have their satellites. So combiningly, we have unprecedented volume of data set to utilize. So this is the time when we can utilize those for any large-scale environmental monitoring. So what opportunities these data set exist, what they give? So this is one example of what you call a Sentinel-3 data set. So this is a coarse scale data, but gives us a quite good repeat cycle and global coverage. And the image provides here is covering Barbados. And the satellite has the capability of capturing quite wider area at one point of time. So we see clouds and like some oceans around, but not much anything in that. But what we do is we transform these images to some of the spectral indices. And this is one of the index which is about chlorophyll information. And when we start putting that index here, so we start to see much more clearly other features. For example, those lines going around are the sargassum mats that are floating around the island. We can see the vegetation over the island. So transforming the data gives us that picture of where things are and where particularly sargassum are. And then we can zoom in with the capability. Rather than going at a much bigger, wider scale, we can zoom in. And this is an example of the same area, but using a satellite sensor called Sentinel-2 multispectral imager. And here we see much more detail. But again, if we apply the similar principle of transforming into various images, then this is a different vegetation characteristic, and here we can see them much more clearly. So even individual mats, we can see their dimension and see the sheer length of those and help us to develop predictions further down the line. So that gives us the regional capability, and then we can also put together a lot of images. So this is a time series of animation over like eastern side of Barbados, where we start to see how the sargassum mats are evolving through time. You see all these red kind of color are the mats, and we can really see the pattern. And this is within a month's time, and see how they're forming and going through the currents and then reforming in the same place over time. So that's why the whole point is they're quite dynamic, and that's why we need a much regular monitoring of those. Once we identify those which are floating, then the next step is to identify when they are beached onto a beach. And when they landed on a beach, we need to know how much is there. So in particular cases, we can utilize some high-resolution remote sensing data set, but also we can utilize unmanned aerial systems like drones. And this example, in this project, we try to look into various areas. So we look into Barbados, in Jamaica, and try to explore the power of drone images for automatic classification of the amount that is being beached. So these are three areas you see. So Kingston in Jamaica, and Manchilian in Jamaica, and also Walker's Beach in Barbados. All of these were constantly monitored, and that gives you the ability of utilizing just off-the-shelf drones to collect this data set. And then what we can do is we can put this data set into what we call as an image classification program. So we can automatically then classify different categories of sargassum that was beached here. And in this case, we see how they're changing over time. And you can automate this system and help the manager and the planner to get instantaneous information about how much is there. And then, further inform the management and planning of this beach, of the sargassum. Once they are beached, also there is information that is missing is about what are the different type of species, because that's useful in terms of the valorization process. And maybe they have different chemical constituents that may make them useful for a specific purpose. So not only just knowing how much is where they're landed, but also more about the specific type. So here you can utilize what we call a close range remote sensing. So utilizing something called the spectral reflectance instruments, and that can measure and gives us a detailed characteristic of each of the species. And we are hoping that each species will have a different spectral response, and that can help to distinguish them. And once we get that clear understanding where it is, then or what is the specific feature that makes it distinguishable, then we can probably scale that using different sensing technology. This is an example of one of those spectral response curves. So the green line here is an example of a line from a spectral curve from an oak leaves or normal vegetation on terrestrial, and the blue and the red are two different type of sargassum. In this case, we got one which is fresh sargassum, and the red one, and the blue one is an old sargassum. So what we see is the clear separation between them, and particular part of the curve is much more distinguishable. And we can utilize this information to develop new sensors to directly identify them. So I'm hoping some of these will be covered in the videos in the following sections. But also there are a few challenges that remain in terms of remote sensing. So we have issues around cloud, as we have seen in all those images, and that's kind of hinders our ability to detect them using optical data set. Particularly, we are quite challenging to get something in the west coast of Africa, which is affected by this. And in that case, other forms of data set, such as synthetic aperture radar or the microwave data, which gives the day and night coverage and cloud penetration probability, can be utilized. But also we can combine multiple data set. We can combine the SAR data with the optical data to provide complementary information. And one of the key challenges up until now is understanding the volume of either the floating sargassum and also the beached sargassum. So there has been some progress made in terms of estimating volume, but I feel the role of the sensing technology is there, and which can be utilized to provide a bit more robust estimation. And moving forward, we may need to know different species distribution and how much of they are available at specific beach. So that is another challenge that can be that you can look forward to solve in future. Thank you.